Hey, everybody. Welcome to episode number 104. And we're going to start off this episode with a guest, Jeff Spalletta, who's going to tell us about some cool stuff. Hey, Jeff.
Hey everybody, I'm just popping in here because I want to give everybody a heads up that uh, I'm actually sort of championing a new program for contributors around the new pre-releases that are going to come out for the 115 Cilium release. We used to call them snapshots in the last release cycle, and they were introduced last time. And I think these things are great ways for people to contribute because they are binaries built every month with the latest commits that are going to lead into the next release. And starting with this first pre-release in 115, I'm going to try to organize some pre-release testing weeks. Basically, the first week after a pre-release is available, we can hop in on the Slack channel. There's a new Slack channel called Pre-Release Testing that I put together, and get some focused contributor testing and sort of find the sharp corners for the new features or the new PRs that were committed in the last month, right? So the earlier we can test that, that means when we get to release candidates, because the goal is always for release candidates to not have problems, that we would have a lot more sort of interesting use case scenario use that we've tested during the pre-releases. Because like the Cilium feature set is huge, right? And so CI can do individual feature testing, but when you start putting things together, we find where the feature mix it sort of has some sharp corners. Or in the case of 114, when I found when I was sort of playtesting this, there were things documented that said didn't work that I actually found worked in 114 because the features had enhanced in other ways, and then they were able to actually put features together that used to not work. For example, the encryption of external workloads, like the cluster mesh external workload feature, used to not be able to be used when you had WireGuard encryption enabled, but because of the improvements with node level
For node
encryption,
config, yeah.
yeah, it actually made the external workload feature better, sort of as a without intending to, right? So that's the kind of stuff that we can actually dig in on in the pre-releases and sort of help test that. And so I have to put some process together because like the pre-release, I'm expecting to come out at the end of the month, so next week, and then the week after that, so like the starting the first week of September, like September 4th, that Monday. If you drop in the channel, you should see some pinned documents in the pre-release testing channel, just to give an idea of what focus areas to work on. I'm also going to spin up sort of an introduction video around the new Cilium CLI tool. It has a new Helm mode, which makes it really easy to start with the guided documentation if you're a new person or a new contributor who wants to test, and then start turning on features one at a time, because the CLI tool does the automation of figuring out what your specific needs are for that cluster you're going to install into. And then the Helm mode lets you just upgrade that by enabling new features. So you get the best of both worlds. Uh, there's a lot to talk about the Helm mode. It's actually really interesting. Uh, there's a lot there. So that's just what I want to say. Watch out for it. It's a sort of a new contributor program. I'm trying to so we can get it. We can pull as much out of those pre-releases. I just think there's a wealth of opportunity there because you don't have to build from source anymore, which is a just a higher bar to do, right? Um, and because the developers, the maintainers are putting this out there, I think we can really add some value to the testing early on in every release cycle moving forward.
Awesome. And I've actually put a link into the chat. That link will take you to the Cilium Slack. That is the pre-release testing channel. You can just click on that, and it'll just put you right into that channel. So you'll be prepared for what's happening there. Awesome. Well, thank you, Jeff, for
Okay.
jumping by and telling us about that. That does sound pretty cool. I mean, I love the idea of like making use of it. I was actually just looking at like to give a little bit more context, like inside of with the Cilium CLI, you can do a thing, Cilium install -- list versions, and you can see all the versions that are available to you. And these are the snapshots that Jeff is talking about that are new ways that we're actually packaging up the software. So the release candidates are like code freeze. That's everything that's going to go into
Right.
it. We're doing testing and pulling up and solving things like regressions and those sorts of things. Snapshots are a different mechanism, as you pointed out, which is that like this is all the code that's in the box on the state. Let's take a
Right.
snapshot. See what it looks like.
Yeah, they used to be called snapshots, and the reason why they're being moved to called pre-releases is just an alphabetical ordering. Because
Yeah.
if you sort them, pre-release comes before release candidate, whereas snapshot comes after. So it just becomes a little more logical in terms of version ordering if the name changes. So from now on, they're going to be called pre-releases, and they will come out roughly monthly, I believe, is the intention, and then that leads to release candidates, and hopefully, if we poke at the pre-releases and the release candidates are all the problems are solved, right? And the release candidates are basically as good as gold.
Nice. Awesome. Well, thank you very much for stopping by.
Yep, I'm gonna pop off now and let you do your demo.
Mutual Authentication Lab. But enjoy your weekend. But cool. All right. So this is a redo or a retake on of an episode from 2 weeks ago when I was going to explore the Mutual Authentication Lab, the new Mutual Authentication Lab. So let me show you where that is so that you can also see it and you can also kind of get started on it. If you go to isovalent.com/labs and you look for mutual authentication with Cilium, this is the lab that we're going to be doing. So if you want to try this out with me, this is a great time to fill in your information, hit submit, and go ahead and start this lab. And that way, when I get through the news here, your lab will be ready to go and you'll be ready to do that with me. In the meantime, I'm going to do a similar thing myself. I'm going to go ahead. Oh, that's not what I wanted. Instruct. I'm going to go ahead and pull that up myself and go ahead and start that lab. Filter options. There we go. So it's about a 90-minute lab. It's going to be a bit of work for us to get through here. This is the page you're going to see after you have entered your information, and it gives us a little bit of information about the environment. So we're going to do mutual authentication and MTLS background. We're going to talk about the difference. Then we're going to jump right into the lab and start working through our content. Before I do that, though, what I'm going to do here is I'm going to hit Start Track. And then down here on the right, you can see it's going to be a couple minutes while everything is getting booted up. And that is why it would be a great idea, if you want to do this, that you would just go to isovalent.com/labs, click on Mutual Authentication with Cilium, enter your information, hit submit, and then go ahead and start up that lab now so that as I'm going through the news this week, you have that happening in the background. All right. And hello. Good to see you. Welcome, welcome. So the news this week, there is all kinds of news. There is actually an update here on the eBPF Summit. So obviously you can still register. That's pretty great. But there is now a schedule up at the top that shows the entire schedule for everything that's coming. We have Brendan Gregg, Jin Yang, we have a CTF, we have a bunch of really great folks just from all across the industry coming to talk about different mechanisms that they're leveraging with Cilium. Now, whether they're using Cilium to do tracing, whether they're using Cilium to support packages like Inspector Gadget, making BPF trace more powerful. Kyle's talk on making minifying containers with Slim Toolkit and eBPF leveraging Tetragon's file system activity tracing. Just lots of really great content if you want to learn more about eBPF and kind of explore that whole space. So that is coming right up. It will be happening on the 13th of November. And I'm really looking forward to co-hosting that with Liz Rice. So definitely come join us for that. The schedule's out. You can register. It's a free registration. You should totally register. It's awesome. The most recent news is from August 22nd. And there's a lot of really good stuff in here. There's BPF agent and eBPF for monitoring at DoorDash. So this is eBPF that DoorDash uses. We could take a look at that. I'm kind of curious myself. Patrick Rogers has written up a whole blog post talking about like what they're actually doing with BPF, leveraging BCC and GoBPF libraries, and using it to. So he's running K-probes and trace points. I wonder if this person has considered leveraging Tetragon instead of leveraging their own homegrown stuff. But yeah, like they're doing a lot of the same stuff that or some of the same stuff that we do in Tetragon, kind of built in here. That's pretty cool. Wow. And then we have a bunch of other technical ones. We have Cilium decoding the packet path with security groups for pods in EKS. We'll delve into how Cilium can be used alongside security groups for EKS pods in clusters when running in chaining mode. We have a VED eBPF, kernel exploit and rootkit detection using eBPF. So when you see events that actually add up to things that you think are considered to be a risk, that's another pretty interesting tool out there. eBPF networking isovalent with Liz Rice, episode 63 of the open source underdogs. That should be pretty fun. Silly Mutual Auth DIY, an article written by Philip Bogerts. So he's actually taking you through that same effort that we're going to do in our lab today. So you don't actually have to go through all of the work that Philip did. You can actually do this in a lab. Yeah, lots of really good stuff out there this week. So if you are interested in this kind of content, you can subscribe to this newsletter just by clicking the subscribe button down here at the bottom, and then you will get that newsletter every week. And you can tune in once a week to listen to us talk about it. Let's take a look at our mutual auth lab. It looks like our lab is ready to start. So I'm going to jump in, and this time I want to finish this thing because last time I got kind of messed up by the whole I had a power issue last time that basically meant that I had overloaded a power supply and it had cut power off to my monitors, and I was suddenly unable to actually get them back. So I had to bail out in the middle of like doing this lab. That was kind of bad, but I'm glad that we're back here. So Cilium was installed. Let's take a look around at our environment. Get nodes. You can see we have 3 nodes. Kubectl get pod -a. Let's see, we have Cilium installed. We have the Spire agent and Spire server installed. Cilium was installed during the lab boot up and was deployed with the following Helm tags: authentication mutual, port 4250, Spire enabled true, install enabled true, and namespace Cilium Spire auth. Pause. You have that. View with Cilium Spire, not Cilium Spire auth. That's an interesting one. That's probably a bug. So, if you're not familiar with Spiffy and Spire, we will chat more about it. But this is actually a project that was instantiated, or it was one of the brainchilds of a good friend, Joe Beta, who came up with some of the ideas behind this when he left Google and worked on Kubernetes and all of that whole space. And so it's actually pretty neat to see it kind of coming to another product that I'm working on in Cilium. So that's pretty exciting. So Spiffy stands for Service Production Identity for Everyone Else. And it really means that you have the ability to associate service identity or a service identity with every one of your services, and then you can use that identity to handle things like mutual authentication between services. So if it is important to you that one service is able to authenticate with another service, how can you enable that functionality without requiring that the application itself has the certificates and it is going through the process of authenticating to that service? Can we move that authentication step? Can we decouple that authentication step and make it a step that is handled transparently from the workload rather than having the workload do the authentication itself? And that is what we're here to explore in this lab. Let's go make sure that mutual auth was enabled. Looks like mesh auth enabled is true. We have a GC interval. We have the mutual listener port. We have the Spire server in Cilium Spire namespace. All of that is configured. Note that the default Spire settings can be customized, so you could actually specify a different domain for those sorts of things. Note that while mutual authentication has been enabled globally, it won't apply to workloads unless a network policy applicable to these workloads has authentication mode required setting set. You will learn more about this in the upcoming tasks. No typo. All right, I got to fix this stuff. Let's also debug log level let's also set the debug log level, as this will be useful to show the actual mutual authentication later on. So let's go ahead and do that. Boop. And when you use the Cilium CLI to change a config setting, what it will do is it will also roll the Cilium pods, because you can see this is a config map. And when we make that change, we're updating the config map, and rolling the dependent pods is just a part of it. We'll do a check to make sure everything is as it should be. All right, let's deploy our demo app. So let's deploy the Star Wars app using the Getting Started with Cilium lab, and that were used in the Getting Started with Cilium lab. And we will build on this demo app and improve the security posture by enabling mutual authentication. So in this example, we'll be looking at the mutual authentication we'll be adding mutual authentication to the Star Wars demo. And let's go ahead and get started here. So I'm going to go ahead and copy these and paste them in. And what we can see what was created was, we can see that there is service Death Star. We have a deployment called Death Star. We have a pod called TIE Fighter, a pod called X-Wing, and a Cilium network policy called Cilium Network Policy Rule 1 was all created. Let's take a look at Rule 1 and see what it says. So this policy is an L3, L4 policy to restrict Death Star access to Empire ships only. And the way that we determine that is that we will select endpoint selector is the class Death Star, org Empire, and then we're allowing ingress from endpoints matching the labels org Empire. We're allowing that ingress on port 80 in protocol TCP. So yeah, that makes sense. We can check the network policy. Let's verify that the connectivity model is the one expected. First verify that the Death Star deployment is ready. Doing a rollout status, we can see that it has been deployed successfully. Next, check if the TIE fighters can connect. And they can. Next, check if the X-Wings can connect. No. Command terminated because it timed out. So that's what we wanted. So is this secure? By this stage, the Empire feels like they have established a strong policy model, which should match the model below, right? Allowing for TIE fighters to actually interact with the Death Stars, but the X-Wing or the Alliance organization should not be able to access it. The X-Wing cannot connect to the Death Star, and while the Empire security officers are aware an HTTP call to a particular path might cause Death Star to explode, surely no officers would want to cause damage to the Empire. The Empire is safe, or is it? Let's find out. So despite the presence of these network policies, the rebels were somehow able to take control of a TIE fighter and cause the Death Star to explode. With no means to verify the identity of the TIE fighter pilot, the Imperial fleet was compromised. And the rebels managed to blow up the Death Star again. The Emperor was pretty annoyed, and he brought in a new officer, namely you, to fix the Empire's security posture. So Palpatine wants you to implement an MTLS-based mutual authentication so that the next Death Star is safe. And by using MTLS-based mutual authentication, the Empire can add strong identity authentication using X509 certificates. Let's go ahead and implement that. So rolling out mutual authentication with Cilium is as simple as adding the following to an existing or new Cilium network policy. Basically, we're looking for egress or ingress policy. We're going to set authentication mode to require. So let's go ahead and do that now. So let's take a look at this policy. This policy has a couple of different sections. Actually, this policy is on ingress at the moment. So this is a mutual authentication enabled L7 policy. Ingress from endpoints matching the org empire, authentication mode required, 2 ports, on port 80 and protocol TCP. Rules, HTTP method post path v1 request landing. So we're saying that the only ones that can actually do this post to v1 request landing are the ones that match our endpoints here. So they have to have a label org equals empire. And before they can even proceed to that point, they have to authenticate with us, right? So pretty interesting stuff. So let's go ahead and apply that. And we have configured rule 1, so we just basically changed the way that rule 1 was working by adding that other stanza. Let's go ahead and check again, see if the TIE Fighter can still do stuff. And it can. That works. And then let's try the TIE Fighter to the exox port path, right? So what this is going to do, because of these pieces, we're saying I only want even a trusted entity to be able to do a post to the request landing endpoint, but not to the exhaust port endpoint. So let's try again from TIE Fighter. Even though they do have access to land, do they have access to, oh, I didn't copy the next one down, to the exhaust port? The answer is no. Right? And this access denied is actually coming from Cilium directly. So that access denied piece, that rule is being enforced by us, not by the application. So when they're getting access denied, that access denied is coming from Cilium, not from the Death Star's exhaust port. Interesting stuff. So this third one should time out thanks to the L3, L4 policy, but has mutual authentication actually happened? So let's verify this in the next challenge. Palpatine is not convinced that the Death Star is entirely secured because he's, a bit paranoid, and he wants to see an evidence of mutual authentication handshake. He needs observability. And when we talk about observability, we talk about Hubble. So Hubble is a fully distributed networking and security observability platform, and Hubble now provides logs and insight into mutual authentication. So let's take a look at what Hubble can show us about this. You've got to make sure that you are running at least Hubble version 0.12.0. And we're going to observe the mutual authentication in Hubble. So let's go ahead and make our copy here. And then let's take a look at the so we do see the drops. Now let's look at the TIE Fighter hitting request landing. Oh. And we see the TIE Fighter, we're saying authentication required. And we're seeing authentication required because because you need to authenticate to be able to get to that part of it. Again, this is expected. The first packet from TIE Fighter to Death Star is dropped, as this is how Cilium is notified to start the mutual authentication process. You should see a similar behavior when looking for flows with the policy verdict filter. And we can even see what is being used for authentication. So authentication spire. I'm actually curious about this one. -O JSON DB. Let's take a look at what we see in the more. So what this does is it shows us more information about the event. So in the overall Hubble observe, we can actually see like whether this was actually whether we were able to, we see kind of like an abbreviated version of this information with just the information that we actually care about, and that makes it easy for us to parse and visually. When we output the JSON, we actually see all of the rest of the metadata associated with that event. So we can see all of the different labels that are associated with it. We can see the pod names. We can see the workloads. We can see the node names, all of this other types of information, including the event type, the traffic the traffic direction, the policy match type, whether it is a reply or not. All of this information is available to us. So verdict redirected, auth type spire. Very cool. Yeah, lots of really good information here. So when we look at these three logs, we can see the allowed log with no mutual auth. The first request was allowed as it happened before we applied mutual authentication. Note that the auth spire is not the error message. And then the denied log, the second request was denied because mutual authentication had not yet completed. And then the allowed mutual auth, which looks like the piece that actually describes that auth aspire, that last one was a successful request, as the handshake was successful. So now we can actually prove that we've actually done the entire identity the entire identity handshake. Sorry. Because you can see those requests. Auth spire. So there's a forward packet, unauthenticated forward packet, a forwarded packet that is unauthenticated. Then we actually see, oh, we have to actually authenticate this. Then we see the denied, and then we see the allowed. Awesome. All right. Next up, what is the next part of our challenge here? We've shown that we have mutual auth, and we've shown in the event that we actually do see mutual auth as an element of the event that we see that is allowed. Let's hit the next one. Mutual authentication quiz. Now this one actually comes with a badge, I think. So I'm not going to answer these questions live in this session, because that would be kind of, I feel like, robbing you the opportunity to explore these questions. But I will read them. So the idea of this particular part of the quiz is to select all answers that apply about mutual authentication with Cilium, and then read through those and pick the ones that you think are the correct answers. So the first one is enabling mutual authentication on Cilium requires to install, manage, and configure a Spire server. The transparent encryption feature encrypts data at rest. The Hubble CLI provides insight into mutual authentication process. Enabling mutual authentication between two workloads requires enabling the feature globally. Enabling mutual authentication between two workloads requires applying authentication mode required to a Cilium network policy. Now remember, you're going to select as many answers as are correct. So you're probably going to select multiple of these. Skip. A suspicious emperor. The Emperor's paranoia is getting kind of out of control. And while you impressed him with your knowledge of cloud native security, he wants to know exactly where the identities of the officers are stored and whether these certificates are automatically issued and rotated. And it's time for you to explain to the Cilium how Cilium, or to the Emperor, how Cilium integrates with Spiffy. So, identity management. To address the challenges of identity verification in dynamic environments, we need a framework to secure identity verification for distributed systems. In Cilium's current mutual auth support, that is provided by Spiffy, Secure Production Identity Framework for Everyone. Here are some of the benefits of Spiffy, trustworthy identity issuance. So Spiffy provides a standardized mechanism for issuing and managing identities. It ensures that each service in a distributed system receives a unique and verifiable, cryptographically verifiable identity, even in dynamic environments where services may scale up or down frequently. The identity attestation that Spiffy allows services to provide identities through attestation. It ensures that services can demonstrate their authenticity and integrity by providing verifiable evidence about their identity, such as digital signatures or cryptographic proofs. In dynamic and scalable environments, Spiffy addresses the challenges of identity management in dynamic environments. It supports automatic identity issuance, rotation, and revocation, which are critical in cloud-native architectures where services may be constantly deployed, updated, or retired. And by combining Cilium's mutual authentication with Spiffy, we establish a robust and scalable security infrastructure that provides strong mutual authentication and verifiable identities in dynamic environments. So Cilium and Spiffy. So Spiffy provides an API model that allows workloads to request an identity from a central server. In our case, the workload means the same thing as a Cilium security identity does, a set of pods as described by a label set. A Spiffy identity is a subclass of a URI, or Universal Resource Allocator, and looks something like this. So we'll have the Spiffy domain, and then we'll have a path with like encoded information in it. There are two main parts of a Spire setup. A central Spire server, which forms the root of trust for the trust domain. You can consider this to be like the CA certificate that it's going to issue and sign identities that are then handed out to those service identities that we create. A per node Spire agent, which first gets its own identity from the Spire server and then validates the identity requests of workloads running locally on that node. When a workload wants to get its identity, usually at startup, it connects to the local Spire agent using the Spiffy Workload API and describes itself to the agent. The Spire agent then checks the workload to is who it really says it is, and then connects to the Spire server and attests that the workload is requesting an identity and that request is valid. So the Spiffy, the request and the Spire agent kind of work together to make sure that before I give you an identity, that like I understand that this workload should be here, that it has attested information that only it can know. There's some stuff that the agent actually has to be able to verify before actually allocating an identity to some other workload on that node. The Spire agent checks a number of things about the workload, that the pod is actually running on the node it's coming from, that the labels match, etc. This is what I was talking about by the attestation piece. So we're checking against the data. We're checking not just the data that is made as part of the request, we're also going and verifying that data is real. Once the Spire agent has requested an identity from the Spire server, it passes it back to the workload in the SVID, the Spiffy Verified Identity Document format. And this document includes a TLS key pair in the X509 version. In the usual flow for Spire, the workload requests its own information from the Spire server. And in the Cilium support for Spiffy, the Cilium agent gets a common Spiffy identity and can themselves ask for identities on behalf of other workloads. So let's learn more. A Spire server was automatically deployed when installing Cilium when you enabled the service mesh piece of it. Spire environment will manage TLS certificates for workloads managed by Cilium. Let's verify Spire health. We'll do kubectl all dash n Cilium Spire. See, the Spire server is running. We can have a Spire server agent. If I were to do -o wide, you can see that these are running on the workers, but nothing's running on the control plane, which is in itself kind of interesting. I would have thought that the agent would sit on every node. Yeah, that's probably a bug. Interesting. So likely what's happening here, kubectl get deployment dash n Spire. What the daemon said, isn't it? Yeah. Yeah. So the bug is probably that tolerations in this case is not set to allow deployment into the control plane. Interesting. Yeah. So that's the thing. We'll probably want to get that fixed so that when you do deploy a workload on the control plane node, if you decide to do so, that at least it could also still generate a Spire identity. At the moment, that would not work. So the next thing we're going to do is we're going to do a health check on the Spire server. So let's exec in and do a healthy and do a health check. We can see that the server is healthy. You can also see what other commands we could run. So nice. We can see federation. We can see JWT's tokens. We can validate stuff. Pretty cool. Let's verify the list of Spire agents. These are the two that we know about. These are attested Spire agents. Note that there are only 2 agents, 1 per node, and we have 2 nodes in this cluster. Notice that the Spire server uses Kubernetes Projected Service Account. That's what the PSAT is. To verify the identity of a Spire agent running on a Kubernetes cluster. Let's verify the spiffy identity for Cilium. So we exec back into Spire, and we use the Spire server command to show us the entry for this particular path. And inside of there, we can see the spiffy ID and selector fields, which point to 2 workloads, the Cilium agent and the Cilium operator. So this one talks to the operator, or this one is representative of the operator, and this one is a representative of the agent. Now let's verify that the Cilium operator has registered identities with the Spire server on behalf of the workloads, the Kubernetes pods. So let's take a look at those. Note that even though there are 2 of these pods, they share the same Cilium identity because they use the same set of Kubernetes labels. The spiffy ID that uniquely identifies the workload is based on the Cilium identity. It follows spiffy.cilium identity and then the identity format. So to verify that the Death Star pods have a registered spiffy identity on the Spire server, let's do a query for it. So here we are basically coupling the identity of that workload. The parent that actually made the request was the Cilium operator. The identity is 1440. If I do kubectl Cilium identity 14400, go to YAML, I can tie that back to what is actually produced, right? So the identity is showing up in here with just the identity number, identity 1440, and I do kubectl get Cilium identities 14400, and I can see that that is the Death Star. All right. So an SVID is a document with which a workload provides its identity to a resource or a caller. An SVID is considered valid if it has been signed by an authority within SPIFFE ID's trust domain. In our case, the Cilium operator and the Cilium agent are both within SPIFFE's trust domain. An SVID contains a single SPIFFE ID, which represents the identity of a service presenting it. It encodes the SPIFFE ID in a cryptographically verifiable document in the X509 certificate. One of the reasons for choosing Spire for our implementation of Cilium mutual authentication is that it will automatically rekey SVIDs before their certificates expire. And when this happens, it will notify the SVID watchers, which includes the Cilium agent itself. Really cool. And you can see the expiration time, and you can see the serial number of the certificate itself. And when these actually come up to expiration, SPIFFE will automatically rotate them. Nice. Our next challenge, mutual authentication quiz. You know what I'm going to do here? I'm going to read the questions, and I'm going to skip it, just like I did last time. So select all answers that apply about the mutual authentication with Cilium. So in this case, the answers are: the Cilium operator is responsible for creating Spire entries for each Cilium identity. SPIFFE is a production-ready implementation of Spire. Through Spire, Cilium TLS certificates are automatically managed and frequently rotated. SPIFFE stands for Secure Production Identity Framework for Everyone. SPIFFE stands for Systematic Prevention of Identity Forgery and Fraudulent Exploits. All right, I'm laughing a little bit. Okay, mutual authentication recap. Before we move on, let's review the mutual authentication process by examining the logs on the Cilium agents. One way to review what actually happened during the mutual authentication is to access the logs on the Cilium agents on the worker nodes. Do you remember in the beginning of the lab when we turned on Cilium debug logs? Well, now it's time to make use of this, and we can do that with grep. We should see the output that we see here, right? Where we see a policy is requiring authentication. We're validating the server SNI. We're validating the certificate. We've validated the certificate. We're successfully authenticated. Policy, and then again in the other direction. So a network policy with authentication mode required was created and will apply to traffic with identity TIE Fighter toward identity Death Star. The first packet from TIE Fighter Death Star is dropped, and Cilium is notified to start the mutual authentication process. And further packets will be dropped until the mutual authentication has completed. The Cilium agent retrieves the identity for a TIE Fighter, connects to the node where the Death Star pod is running, and performs a mutual TLS authentication handshake, validating server SNI and validated certificate logs. That's what we're seeing that happen there. When the handshake is successfully authenticated log, mutual authentication is now complete. Packets from TIE Fighter to Death Star will now flow until the network policy is removed and the entry expires, which is when the certificate does. Okay. The final exam challenge. If you complete the questions in this final exam challenge, you will get this really cool sticker. And actually, if you see us in person at KubeCon, we're going to have these stickers to give you out in person as well. So if you come and you passed some of these labs and you haven't received your sticker in the mail or anything, you can actually come by at KubeCon in our event zone, and we can actually share those stickers with you directly. It'll be really fun. I'm looking forward to meeting a bunch of people who have actually gone through a lot of these labs. So for this exam, a client, pod worker, and a server, eCHO, have been deployed in the exam namespace. Along with an L7 Cilium network policy to only allow the client to connect to the server over a specific HTTP path. This policy is matching endpoint selector up echo. It's allowing ingress from pod worker on port 8080 protocol TCP, and it's allowing get headers. You can find all the manifests that we used in the exam directory. The Cilium network policy is echo cnp.yaml. You will start by using the previously deployed Cilium environment with mutual authentication feature enabled and the Spire server deployed. Your task is to modify the network policy to only allow ingress access to the eCHO workload from mutually authenticated workloads. Don't forget to apply the network policy to the cluster. So you should still have rule 1 here, and let's take a look. Ah, yes. Yeah, I can see the answer here. So if we look at that, and then we also look at exam echo CNP, we should be able to spot a difference. Skip. And that, my friends, is the Mutual Authentication Lab. I hope that you found that educational, and I hope that you actually completed the lab. And if you did, it'd be great to hear like that you have actually done that work. And let us know what you think about it. Like, let me know if you let us know if you think it's too technical or if you think it's the right level of engagement. If you think these things are awesome, I personally think they're awesome. But I'd love to hear more from you and hear like what you think about all of that stuff. So, tons more labs out there. One of the other things I wanted to call out here is that this mechanism is actually very similar to Google's application layer transport, wherein Cilium's MTLS-based mutual authentication splits the handshake protocol and record protocol apart and performs the handshake out of band of the actual packet flow. The MTLS-based authentication layer of Cilium fulfills the authentication requirement of a connection, whereas the existing in-kernel encryption layer provides the confidentiality and integrity parts. To learn more about encryption on Cilium, you should take the Transparent Encryption Lab. But that is a really interesting point and definitely worth understanding. What that means is that when we do MTLS, when we're using mutual authentication, we're actually using that just to verify the identity of services back and forth. And then we're leveraging IPsec or WireGuard in the underlying implementation for the actual encryption of traffic on the wire. So, I mean, it's a pretty compelling solution. And that's actually also how we get away with being able to support not just TCP traffic. We can support this mechanism, this authentication mechanism for any type of traffic because it is decoupled from the transport itself. All right. Well, like I said, I hope that was helpful. I hope that that was educational. And if you're out there and enjoying what is going to be hopefully a really nice weekend, I hope that you do have a great time. So thanks for tuning in. I will see you all in a couple of weeks. Have a great time. and have a great weekend. Let me stop sharing my desktop. And we'll see you all next time.